I'm going to apologize right now. My little tablet isn't working, so I'll be writing with my mouse today. So my writing won't be as good as it is, but we'll do the best we can. So chapter 4.5 is writing a function rule. So now what we're getting into is instead of you having like the function and explaining it in words or on a table or in a graph, you're going to be given a situation and you're going to write it as an equation. Okay, so we're going to write equations that represent functions. Remember, functions is just like a situation that has an input and an output. Okay, so here is our first situation. You can apparently estimate the temperature by counting the number of chirps of a snowy tree cricket. So if you can find one of those, you can estimate the temperature outside. The way that you do that is the outdoor temperature is about 40 degrees Fahrenheit more than 1/4 the number of chirps the cricket makes in 1 minute. What's the function rule? So what's the equation that represents that situation? There are things that you have to look for, okay? Obviously, anytime numbers come in, there's a good chance that those will have an important part of your equation. But also, identify the variables first. What are our two variables that we're going to be looking at for this? They are outdoor temperature and the number of chirps in 1 minute. Okay, I guess in 1 minute doesn't matter. It would if you're actually counting them, but it doesn't matter for our function. So we need to come up with variables for those. So outdoor temperature I'm going to call T, and number of chirps I'm going to call C. So the temperature is, if you remember, what does the word is usually stand for? An equals. So T, the temperature, is, okay, 40 degrees Fahrenheit more than. What does more than usually represent? Usually a plus sign, right? Okay, so we're going to be adding 40. Now it doesn't matter if you add 40 on the right side or 40 on the left side, right? When you add, it doesn't matter if they're flipped around or not. I usually always like putting it on the right, but that's totally up to you. Is about 40 more than 1/4 the number of chirps. So 1/4 of, when we have of, I know that it doesn't actually say that, well, it does, sorry. 1/4 the number of chirps. Of is usually multiplied, so 1/4 of the number of chirps, which is C. So now therefore, if it chirped 100 times in a minute, 1/4 of 100 is 25 plus 40. The temperature would be approximately 65 degrees outside. But this is the function that we're looking for. Okay? Here's another one. A landfill has 50,000 tons of waste in it. Each month it accumulates an average of 42,420 more tons of waste. Okay, so we got of a couple of times. 420 more tons of waste each month. So each month, 420 of waste. That kind of sounds like multiplication right there, right? So what are our two variables? Our two variables are how much waste is in it and how many months there have been. So I'm going to represent months with M and waste with a W. So the waste will equal 420 tons each month. So when we're doing each, we're doing 420 times each month. So that's times M. And then you ask yourself, did we start with anything? Like, was there anything that we started at? Well, yeah, we started with 50,000 tons. So we have to add the 50,000 tons that we started with. Now again, these two could be flipped. It could look like this.
Dylan, once you have a message on your side of buffer.
It could look like 50,000 plus 420 M equals W. But this is 420 times the number of months plus the 50,000 that we started with. Let's try one more. A concert seating plan is shown below. Reserved seating is sold out. Okay. Total revenue from ticket sales will depend on the number of general admission, general seating tickets sold. Write a function rule to represent this situation. What is the maximum possible total revenue? All right. What are our variables? Like, what are we looking for? Well, we're looking for total revenue, so like total amount of money made. So I'm going to use an R for total revenue. And what is the thing that's changing? The only thing that can change is the number of general admission seats sold. They already told us that this section right here is completely sold out. Okay? If it's completely sold out, that's added on no matter what, because that's always already sold. So we are looking for the total revenue. So I'm going to call the total revenue R. So R is going to equal however many tickets we sell here. Okay? How much is each seat? $10, right? So what do we want to call each general admission? I'm going to call each general admission seat a G. So $10 per G, however many general admission seats were sold, plus all of the money they made down here. Well, how much money did they make down there? There's 10 rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 going up this way. Times 12 seats each. Times $25 per seat. So that comes out to be, let's see, 250. 250 times 12 should be about 3,000. Yep, 3,000. So our function rule is R equals 10G plus 3,000. So what is the maximum? So now that's our function rule, and then they ask us one other question. What is the maximum possible total revenue? Well, the maximum would happen when? The maximum would happen if we sold out this entire section here. And this entire section has 30 rows and 16 seats. So how many people is that? 30 times 16 gives us 480. So if we sold 480 general admission seats, 10 times 480, plus the $3,000 that was already made from the reserved, that comes out to be this 4,800 plus 3,000. The most we could possibly make would be $7,800. And those are functions. So what you have to do, make sure that you're paying attention to words like, okay, reserved seating is. Is usually equals. So reserved seating is means equals. Sometimes it also, total revenue, ticket sales will depend on. So here's another one, depend on. It's the same thing. But reserved seating is sold out, so it equals, meaning it equals being sold out. Total revenue will depend on, again, that can be representative of an equal sign as well. The number of general seating tickets sold. So we have to figure out how much do you make per general seating. And that's $10 per, plus the reserve that was already sold out. So look for a bunch of those keywords. Make sure that you identify right away what variables you need, which one's your dependent variable, which one's your independent variable, and so on. Again, sorry about the writing. I hope to get my tablet fixed so that my handwriting is better for next time.